we're going to look at some additional types of equations. So these are kind of like quadratic equations, sort of the same form where your first exponent is double your middle term. So we can still solve by factoring. If you think about what you will multiply together to get y to the fourth, it's going to have to be y squared and y squared. I mean, it could be like y to the third and y to the first, but that won't work to get y squareds in the middle. I need my last two terms to multiply to -4. Let's see. Now if I think about multiplying that out, yeah, that'll get me a 3y squared in the middle. If I set each factor equal to 0, I'll have y squared minus 1 equals 0 and y squared plus 4 equals 0. Solving each of those, so add 1 and then take the square root of both sides. Don't forget your plus or minus. And then same thing with my other one, subtract 4. Square root of -4 is positive and -2i. So there are my 4 solutions, which I should have 4 because it's y to the 4th power. You, if you don't like to factor, can use the quadratic formula, but if you think about like your middle term is usually what you're getting, you have x equals. This time your middle term is y squared. So if I use the quadratic formula, I'm going to get what y squared is equal to, not what my variable y is equal to. So you can run through the quadratic formula, just like you normally would, plug your values in. Inside your radical, you're going to get, let's see, 9 plus 16, 25. Square root of 25 is going to give you 5 all over 2. Then if you do -3 plus 5 and -3 minus 5, your values that you'll have for y squared are going to be, I think subtracting will get you -8, adding will get you +2. So you get y squared equals -4 and +1, just like we got when we factored. So you get the same solutions if you use the quadratic formula. Just don't forget that your initial solution is y squared. This is still somewhat like a quadratic equation in that your first power is double your power on your middle term. So we can solve this one with factoring. My first two terms have to multiply to get me x plus 1 to the 2/3 power. Well, if you think about multiplying things together, you add their exponents, so that'll be x plus 1 to the 1/3. It also matches your power on your middle term. That's the only way this is going to work. And then my last two terms of my binomials need to multiply to -2. So let's see, -2 and 1. And yeah, that works for my -1 of those in the middle. So if I set each factor equal to 0 and solve it, then I'm gonna kind of run through both these at the same time here. I'm gonna add 2 to both sides of my 1 on the left and subtract 1 from my 1 on the right. And then if you think about 1/3 power, that's the same thing as a cube root. So I'm gonna go ahead and rewrite this as a cube root because I like that better to think about. Now to undo a cube root, I need to raise both sides to the 3rd power. And that'll leave me with x plus 1 equals 8 and x plus 1 equals -1. Subtract 1, you get x equals 7 and x equals, -2. A second option is we can solve this by using a method called substitution, which is not for systems exactly. It's a little bit different. It's basically rewriting the first messy equation in a form that looks a little bit easier to work with. So if I turn my middle term into, let's just say, y, then I can rewrite my equation with my middle term replaced with another variable that's standing in place of it. And then my first term I know is just that term squared. So I could solve the similar equation, y squared minus y minus 2 equals 0, which really I'm going to solve it the same way, either by factoring or quadratic formula. So I'll have y equals 2 and y equals -1 when I do that. And then you have to remember that you're not actually solving this equation for y. We're supposed to be solving for x. And what y stood for was x plus 1 to the 1/3. So I'm going to substitute back in x plus 1 to the 1/3 power, because that's what y was equal to in my rewritten equation. And then I'm going to run through and solve, which if you look, oh, look, I'm right there. I already did this. So you're still going to get x equals 7 and x equals -2. Technically, we should also be checking our solutions on these because we have really radicals involved since we have cube roots. they do both work if you plug them back in and check them. So if you have radicals involved, fractional powers, check. This one has some negative exponents and rational exponents. So actually I'm going to use that substitution method and rewrite this so it looks a little bit nicer. I could just factor it straight up if you'd prefer. I just want to show you another one where we can substitute in case you like that. So if I'm substituting, I'm replacing my x to the negative 1/5 with y, and that means my first term needs to be rewritten as 2y squared because it had that coefficient of 2 out in front. So for my rewritten equation, I am just going to factor it into, let's see, 2y plus 1 and y minus 1. Yeah, that works. Set each factor equal to 0. I'm going to end up with y equals 1, and then y equals negative 1/2. Now you're not done because y is not what I'm trying to solve for. I'm trying to solve for x. And x stood for y to the negative 1/5 power. So I need to turn this back into, instead of y, x to the negative 1/5 power equals negative 1/2. And x to the negative 1/5 power equals positive 1. Those are negative exponents, so I'm going to go ahead and flip it and make it 1 over the 5th root of x, because that's what 1/5 power is. And then if you think about solving, oh, I am out of space here. Let me go up. I am going to multiply both sides by the 5th root of x to get my variable out of the denominator. And that's going to give me just, since my 5th roots divide out to 1 equals negative 1/2 times the 5th root of x. I am going to divide by negative 1/2, or actually just multiply by negative 2. And I'll have negative 2 equals the 5th root of x. And to undo my 5th root, I'll raise both sides to the 5th power. And so you have negative 32 equals x for one of your potential solutions. I boxed it, I checked it, it works. Your second one is just 1 over the 5th root of x equals 1. Again, multiplying both sides by 5th root of x and then raising to the 5th power. This time you just get x equals 1. First thing I'm going to go ahead and do is get 0 on one side by subtracting 2 from both sides. And then I am just going to go ahead and factor this because that's the method I prefer. You could think about what it takes to get you 6x to the negative 2nd and negative 2. So I know it needs to be x to the negative 1st times x to the negative 1st to add my exponents together and get negative 2. I'm not real sure about the 6 though. No, that won't work for my middle term. Let's try 3 and 2 instead. Closer. Even with my experience guessing and checking, I don't always get it right on the first try. Okay, there we go. That'll work. And then I can set each of my factors equal to 0 and solve. So if I subtract 2 from both sides, it's 3x to the negative 1 equals negative 2, and add 1 to both sides, 2x to the negative 1 equals 1. Remember, that is 3 over x, only the x has the negative exponent, not the 3 there. Same with the 2. And then I need to get my variable out of the denominator, so I'm going to multiply both sides by x, which will just leave me with 3 equals negative 2x, and 2 equals x. So you get x equals negative 3 over 2, and x equals 2, which, think about plugging them back in, checking them, because this does have rational expressions like fractions, so you couldn't have 0. You could actually, if you prefer, take your original equation and write it as a rational equation instead, and then go through and get your common denominator like we did yesterday, and then multiply both sides by x squared, get 0 on one side, factor, and go from there. Actually, I kind of like that on this one. So that is an option that you could use as well.